Hi everyone, we are in the next lesson from our StarNet bootcamp. Do you remember last time we talked a bit more what is StarNet? We checked the book. This is the StarNet book. We started here with Remix. We deploy a smart contract there, easily with Remix. Also, we did the exercises with Starlink. Yeah, and you have your homework. You have to finish, all the exercises here. So now we're gonna talk more about Starnet, the Cairo language, the smart contracts here with Cairo, and we're gonna use a different tool, not Remix anymore. We're gonna use VS Codes. We're gonna deploy with local .NET, like with Katana, and testnet with Coerly. So yeah, but before that, we're gonna talk more about Darnet and the smart contract itself. So let's go for it. And yeah, here we are here. Yeah, like I said before. First, you have the introduction video of Starlink ecosystem. Then we talk about smart contract, Remix, Cairo, Starlink, and now we are here. So yeah, let me work like this, much better. Okay, great. So yeah, this is the process how we can compile our program with Cairo. So first we have to, write our smart contract with Cairo 1, that is like a version 0.3 right now. When we do this, when we have our smart contract, we have to compile and we are gonna get some intermediary file. This is going to be the Sierra file, or now it's also called contract class. So, and after that, with this contract class, we are going to get the assembly, Cairo assembly file. So this is like the process we have to go. And all of this is going to be, after this, we're going to send this file to the blockchain, to the Starnet blockchain. I want to show the example of all of this. So this is just for reference. And now we want to talk more about the structure. How is the structure of the Starnet contract? They call it like a dichotomy. So first, we're going to get a contract class. So remember this, we write a smart contracts in Cairo, and then we have to declare a class. So this is like the first step we have to do. After we write a smart contract, we have to declare it. And when we declare the contract, we're going to get this, this code, like I say, from Cairo contract to, we have to compile it from Cairo to Sierra. So this is the first step that we have to do in order, to interact with the blockchain. First, we have to declare, and this is the first step. And here in this file, we can find the ABI function. We have like a section in this Sierra file when they show the ABI. And this is called the class hash. So this is the process. We declare our program, and we're going to get a class hash, which is going to be, a hash number. We're going to get a file, and this file is going to include the ABI like content. Here they mention the class hash changes every time we modify the code. Yeah, every time we, made some changes in the smart contract, if we declare again, the class hash is going to be different next time. But if we don't change anything on the smart contract and we try to declare one more time, we're going to get the same class hash like we did before. So I'm going to explain this also with the code. This is just for reference. And yeah, so this is the first concept, class hash and contract class. And the second concept is the contract instance. So this is like you see, an instance is deployed on a Starnet. Before, when we did the declare, that's it. When we did the declare, it was not deployed. It's just like a class hash, to take a reference of our the deploy. It's gonna need the declare it, the class hash, and with that we can deploy and generate the contract address. So like they say, this contract instance is gonna have the storage of the smart contract. It's gonna be associated with the class hash. That the class hash is the first output from our first step. And with this, we're gonna get the contract address. Let's check this example. It's gonna be more clear. So remember, we can have one class contract or class hash is this one, two, three. And after that, we can deploy our smart contract with this. So this can be a deployment smart contract. This is the instance number one. Here before, we have an instance number 2. This is the instance number 3. But all of them, they are going to share the same class hash. But they are, just different smart contracts. They have different contract address. Although they have the same functionality because they are from the same class hash. So maybe you can also, remember before if you have studied Java language before, we have to create our class. And after we create our class, we have to instance our class. So we can have as many instances as we want, but the class is going to be almost the same always. So this is for a class hash one, and we have a different one. So this is a different program, has a different class hash, but same, we can have as many smart contracts deployed as we want. Yeah, yeah. Now, how do we interact with the blockchain? So, like Ethereum, maybe we have the read functions and the write functions, but in the Starnet ecosystem, if we want to, call a read function, we have to, specify this keyword on our command we want to call. If you want to call, it's like a keyword to, to call the read functions. And if you want to write something or to change the state of your smart contract, yeah, we can call the invoke. So invoke is going to be used, to call functions that they are going to write. They are going to change the state of the smart contract. We are going to see the examples, to check it more clear. And yeah, every time, yeah, like we do a invoke. Every time we change the state, we have to pay a gas fee. And it's going to be a transaction. But for calls, it's going to be free. You can make calls to the blockchain as much as you want. So it's free. So here again, we have this is the types of transactions. Remember, when we declare a program, smart contract, we're gonna get the class hash. But when we do invoke, we can get the instance and deployment account also, we're gonna get the instance. But most of the time, we're gonna work with these two, declare and invoke. Yeah, this is also the overview how the Starnet ecosystem work. We have the main pools when we do the validation of the transactions. It could receive a transaction or it could get like a failed validation. But the most important tool here, component here is the sequencer. So the sequencer is going to take the valid transactions, is going to order a structure, and is going to send it to the prover. So the prover is going to generate a small proof. We can verify this on layer one with Ethereum Starnet. So here the prover is going to send it's going to it's going to generate the proof, and we can verify the layer one Ethereum. So during this process also as well, since they are like Starnet is a layer two, the main the main function of this is like they are going to do the roll up. Yeah, they are going to take a bunch of transactions and do the roll up, generate the proof, and send to the verifier on the layer one. So we continue. We're going to check more about the Starnet contract structure with the anatomy here. So this is the very basic. Every time we want to, build a smart contract in Cairo, we have to add this attribute Starnet contract module for it to be my contract number one, number two, and inside we have the storage. So like we mentioned here, a smart contract must have storage defined for now, even if it's empty, even if you don't use it, but it must be included there. And all of these annotations, attributes, they are also important. We have to we have to follow the rules in order in order we can compile the smart contract. Okay, but there we also have a constructor. We have to add the attribute here for a constructor. It can be any value. So let's say, must we call it constructor as well? Only call it once when deploy the contract. Yeah, only at the time we're going to deploy the smart contract, we have to pass the arguments for this constructor. In case we have, in case we don't have it, we don't send arguments for the constructor. Here, for example, here they take a reference mutation of the contract state. So we can, write the state of the smart contract because we pass here self-reference. So you're gonna check here, it's gonna be a bit different. If we only read the function, we are gonna we're gonna define a snapshot. We're gonna check in the next example, for example. But wait, this is events. Events are always defined as strokes. So this is like how events look like. We have to define here. This is also, yeah, first we have to define here this my event number one inside this enum event. And after that, we have to, define this event one that is this. So if you want to add event two, we have to add here my event two. We have to define the structure here, my event two. So that's the way how Starnet works. See the keys. We have keys here. The keys are indexed and allow quick search when querying the blockchain. Yeah, this is important, especially when you want to, interact or work with the front end side of your contract. They're gonna be listening to the event, so it's gonna be easy to work. It's gonna help a lot on the front end side of your project. The next one, we go to this exposing functions. Yeah, like I mentioned before, we have the read value, the read functions, and the write functions. So in order to expose these functions, we have to add this external D0, like an attribute. And then we can see a read only function or like a view function takes a snapshot of a state as parameter. Yeah, you can see the snapshot is this symbol we can see. So every time we try to we're going to define the read function, we're going to take only a snapshot of the smart context state. So it means you can imagine this like we're gonna take a picture of the actual contract state and we're gonna read it. That's it. We're gonna take a picture of at that moment, at that time of the contract state, and we're gonna read any kind of value that we want. So that's why here we add this symbol. In case we want to write here, in case we want to write a function, it's gonna be external and it's gonna take a mutable reference as a state. So here, this is a difference. Here we don't have this snapshot, but we have this ref. So ref is gonna means like a mutable reference. So here we can apply some write functions. So here we are gonna change the previous value with the new value that we pass here in the arguments. Well, we're going to see all of this in the example later. Interfaces, another different language, Cairo also supports interfaces. Interfaces is actually good for good practice. So we mentioned interfaces ensure that any contract implementing the interface will expose the given function past type. So yeah, this is like your template or maybe your goals when you start, thinking about what your smart contract is gonna do. You're gonna start with this. Just define the interfaces that you're gonna implement later. So this is the way we have to call the interface attribute. We're gonna call a trait and implement this my contract later. So like you can see one more time, similar to Rust language. Some of you have experience with Rust language. So we have this trait. So it's the same meaning with Rust. So one more time, interfaces is standardized how contracts are called, but it's not mandatory, but actually it's a good practice. So like they also mentioned, it helps with better integration with existing apps, like tools and that. And this is also there. They say the right way of exposing functions, we can, better, like they say, only for the implementation block. So all of this is an implementation block. And on top of this, we can, add this annotation. And inside, we can define the function. So this way is much better if we do this. So yeah, this is a really very basic way. It's going to work. We define external here and external here. But this way is much better. We define this on top of our implementation block only one time. It's going to help a lot with better maintainability. It's going to help, debug our contract. Then another important component here is the dispatcher. Dispatcher, they're going to help us, to interact with different smart contracts inside our smart contracts. That's the main meaning. So dispatcher are automatically generated from interfaces. So here, for example, in this piece of code, we just call dispatcher trade a dispatcher, but we didn't, like define explicitly. Like they say, we're gonna get it automatically. So using the dispatcher, the function is executing with the storage and context of a targeted contract. For example, here we're gonna pass. This is our dispatcher. So we're gonna pass data address. Here, this is the data address that is different from our actual core. It's different from our current smart contract. So we're going to generate a dispatcher, and we're going to, call a function, get data function, but it's going to be from a different deployed smart contract. So we're going to check example to get a much better idea of this. So like this library dispatcher, I use it to call a function in a stateless manner using the storage and context of the current contract. We're going to use a current contract, but we are going to call data from the different contract. That's it. Okay, so now we just did a quick review of the basic, structure of a Starnet contract. But now let's check more the code with the real example. So we're going to follow this now. Tooling. We have this basic installation. So remember before we did this, the remix, you deploy there your contract. But now we're going to install, the tools that we need in order to deploy and interact with the smart contract. This time, let me open a bit more. Okay, looks much better. So there are three famous tools we're going to use. One of them is Starkli. Starkli is going to help us in order to deploy and interact with the smart contract, interact with Starnet, the blockchain. Scarb is going to help to compile our code into Sierra. You remember Sierra? And then also into Cairo assembly. And Katana is like our local host. You can think like a server local host or like a local DevNet in order to, it's going to help a lot to connect with the blockchain. So we have to follow this installation. In my case, I already did. You can also follow this, but we're going to check if we have the version. I'm going to open my terminal. I'm going to check if I have the Starkli version. Do this way. Okay. Okay. My Starkli version. Yeah, I have this version. That's good. Scarb version. We have to install, to open and reopen a new terminal. In my case, I did. Check if I have. Yeah, I have this version 0.3.1. Good. And then the Katana. For Katana, you have to install your game engine, but this time we're going to use only the Katana. Sorry, Katana is not here. Katana. Okay, I have all of these tools. Now we can, So make sure that all of this is working on your side, Starkli version, Scarb version, and Katana version. Otherwise, if you get some problems, just let us know how we can help. Yeah, that's good. Now we have this. Yeah, we are gonna follow this tutorial in order to interact with Cairo and Starnet. So like I did, I already did. I applied this command. So then we have this optional part. We are not going to check this now. Yeah, just skip it. And now, we are going to use a Scarb for first time. You can check more the Scarb documentation, but we're going to follow this. So with this command, we're going to create a template of the smart contract. So here, for example, let's clear this. Let me try to maximize a bit more. Wait, I'm not working here. Okay. So we're gonna go with Scarb. Let's say new. We call it my contract. Okay, follow the same. Created my contract. So here I might find my contract in somewhere. My contract is here. So let's go there. CD my contract. Now you can, use any, in order to interact, in order to write your programs. In my case, I use Visual Studio Code. So I'm gonna open this with Visual Studio Code. So I just do like this code, and then yeah, I got this. So here, yeah, I got a template, a predefined program from Scarb. This is the basic. We have the main function. We have a different a second function. Also, we have test here. Uh, the Scarb. Yeah, we have the package, the version, the dependencies we can add. Okay, let's see if Scarb is working well. What we can do here is just to build the contract. So let's do it with Scarb build. So yeah, you can see it has generated this file, the Sierra file in this case. So let's also start test. So yeah, it has run the test here. It's working there. So yeah, it looks like Scarp is working well. We don't need to take too much time explaining this code. Just gonna delete it and create it from scratch because we're more interested on smart contracts. But we just try to play with Scarp. So let's go back to our book here. So yeah, like you see, we got this like a Scarp Cairo file. We're gonna write our smart contract here in this file. Yeah, we have that DOM file to integrate the dependency. Yeah, like you can see on this file, actually we have to add this dependency, all of this, in order to actually work with the smart contract. So we go to the DOM file and we overwrite this. Oh, no. I'm gonna see. Okay, we have this. We're calling to Starnet, this version of Starnet. Also, we're gonna call it here in the target, our new values. So let's delete this. We can try scar clean. It's gonna clean the target much better. Okay, let's follow the. Okay, now the idea is to work with a Katana, our local host. So for this, we have to set up, your wallet and your RPC endpoint to connect with the blockchain. But for this time, in Katana, we have this predefined wallet or account. So we just call like this, and they are gonna do all the work for us. So we have to create a .env file and add this content. So let's do it now. Fine. Oh, my bad. Okay. Okay. So what we said here, we are gonna connect to the blockchain with this account. This call it Katana Zero. But inside here, it has the public key, private key, the address. But now all of this is masked just this name, and we have this past the endpoint of the RPC that is going to be our local Katana. For example, here we can rank a Katana just now. Just follow the Katana disable key. You can see here it has a lot of pre-funded accounts, 1, 2, 3, with the private key accounts, public key. Since they are on local host, they are not real money, but they expose this JSON RPC endpoint in order to work with this. So great. Let's keep Katana running. So now we have this. So yeah, we can deploy our smart contract. But first, let's see how our smart contract looks like. So this is going to be our basic smart contract. I'm going to copy and paste here to the. Okay, this is going to be our smart contract. I'll just call it hello. Let's say this is like our hello world for Starnet. So this first smart contract, like we mentioned, it must have this contract annotation. Then we have the mode. So this is going to be actually the name of our smart contract. Let's call it hello this time. It's going to contain the storage component. So for this, we have to define storage. And this is one element of this storage. I just call it name. Since this is important, remember in Cairo we don't have strings. It's not like a different other language. on Web 2. They have a string, but here we don't have a string. So something similar to string is like a field element. So we have field elements. We call it like felt 252. So in some way, it's gonna simulate a string value, but it's really limited. You only can work with short string values. We're gonna see this. So yeah, we define our storage. So in our constructor, we have to, to set up the values of our elements here. So we call constructor. Remember, we call this ref self. We call ref here because it's a mutable reference of our storage. We're gonna pass the contract state. This is like implicit, but because it's a self, And then we have to pass there like an argument, this value, the value of the name. And here, yeah, they call self name, call self because it's gonna call that, smart contract on storage and then name, call name because name is the same, the same name like here, and then we call the get write in order to modify the state. Good, and then we pass this function, well, this argument here. Like before, we have to call this external and get name, set name. And this time, because it's a get, this is only a read function or a view function. We only pass a snapshot of the smart contract, of the contract state. We read the value of name. And in case we want to change the name, we have to define our set name function. Here again, we pass our mutable reference. We have passed the new value. We have this previous value in case we want, but I think we don't need it. We can try just like this, let these values. Yeah, let's try just like this. We have name and we write. This is a really simple, very, how many lines? 20, 25, 21 lines of code. So the idea is to start always with something small, really small, and then try to evolve, improve little by little. Don't try to make a really big smart contract from the very beginning. Just try to deploy and interact with a small contract. So yeah, now we have this. We also have here this we call the dependencies, or you also have our environment variables. So yeah, we are done. Let's follow the book. What did I mention? Yeah, we insert this code, and then we have to compile. So we have to compile this smart contract. We have to apply Scarb build, and we are gonna check what we're gonna get later. Compile. Oh, sorry, Scarb build. Let's see how it goes. Okay, it was so quick. We got these files. Oh yeah, we have the contract class and the artifacts. Remember, this contract class. We have the ABI at some point. Let's find it. ABI. Oh yeah, here. So here the ABI, we can see our function. We remember get name. Here we have like a set name and more. We're gonna use this file later. So, but this is like the first file that we get after we apply Scarb build. Scarb build is gonna compile our smart contract. Good. Let's follow the book, how it goes. After we compile the contract, we have to read our environment variables. So for this, we have to call this source.env. Let's do it. And then we can make sure if we have this, we already have these environment variables. We can call it, how is the name here? Target account, let's see. Great. So you can see our terminal can read that started account is Katana 0. So it's working, it's good. So it's working this. Now we have to launch Katana. Katana is already launched here. It's waiting for us. And yeah, this is like, we can say the second step. The first step, always you have to build your contract. Then you're gonna get your contract class. The second big step is like, have to declare, like I mentioned before in the slides, we have to declare our smart contract. So we have to pass this file that we got it just a few minutes ago. So it's like this. And this time we're gonna use Starkli. Remember, we have to switch now Before we use Scarb, and now we're going to use Starkli. Starkli declare, and then we have to pass the file, the target, declare target, should be my contract. Let me get, oh no, Starkli target should be that here, that my contract, hello, yeah, contract class, like JSON. Yeah, remember this is a bit different. Before it was Sierra.json, but now we use this concept.class when we talk about smart contracts. So be careful if you have checked maybe a few months ago, you have deployed, you have built, compiled some smart contract. It can be like Sierra.json, but now it's contract class. Some upgrade here. Let's do it. Oh shit, okay. Let's analyze this a bit more. So you see the important one is here. We got our class hash. This is all the process that it takes. But for us, the more important here is if you get this value, so it means it's working. So that's good. We're gonna keep it this value. We're gonna save it later. Let's check in the book. Yeah. So you might find some errors. You can try to solve it here. And then, like they say, successful command execution, you will obtain the class hash. Class hash declared all of these. We also did the same. We got a different class hash, but it's okay. No problem for that. So, like they mentioned, consider this hash as the contract class address. Yeah, it's gonna work like this. But what happens if we want to declare again one more time? We're gonna try to do it again, declare. You can see this not declaring the class because it's already declared, so we get the same class hash again. But what happens if we change here? For example, let's see, stock, storage, name, read. We want to add something here, for example. We want to add some extra value, 32. So we have changed the contract, and let's try to build again. Our build, let's try to compile. You're gonna get it has updated these files. The content has been updated. Let's try to declare, yeah. And you can see now it's a different. The first one we got was this 050, but now we got 073. So yeah, I just made a small change here, but now the class hash is totally different. But since we don't need this, so just gonna delete it. I'm gonna compile again my file. I'm gonna declare again. And yeah, we keep the previous class hash. Great. Now let's move on. We have this like a deploy and starnet smart contract. So remember what we did first is car build we have, and the second step is to declare. So we call it Starkli declare. We got this class hash. Now after that, we have to do is deploy. So remember when we to deploy a smart contract on Katana, because we're using Katana here. Yeah, Katana. It's gonna require what? Your class hash. We already have the class hash and the constructor. We have to pass a constructor. In our example, is this time it's a name. Let's call it, and the type is file. So we have this is the way how we deploy. Starkli deploy. We have the class hash. We pass the class hash, and we have the input parameters. In this case, it's only one parameter. It's name. So it's gonna be Starkli deploy our class hash and the name of the value of the name we want to add. But remember, let's try to play with something there. For example, Starkli deploy. We have to pass this here, this class hash, and then we have to pass a constructor. Its name. Let's call it hello again, and we got an error. So, and they explain here why, because we have to pass hello is supposed to be the name, yeah, the string value, but we have to pass in this way. So we have to pass in the felt format. So we need to convert this short value, this short string to a felt format. How do we accomplish this? We have to call this command. So let's do it. Starkli to string Cairo. In this case, we call it like this. Let's say the value of name is going to be starnet book. So let's call it this way. So yeah, now we got the felt format of a starnet book. Is this all of these hash value? This is the output. And now if we want to deploy, we have to deploy like this. First the clash hash, and second the value of name, that this is the value. Let's do it our way. Starkli deploy. We have to pass the clash hash, and then we have to pass what? This value, this value. Okay, good. This is working here. So we get all of these output, but the most important one is this one, contract deployed, and we have our, no, this is the address of our smart contract. And this is already deployed on Katana. Katana is working here. Katana is working here. This smart contract is deployed there on local .NET. Okay, let's continue. Like I say, yeah, we got this. Great. So now next step, the idea is to interact with the smart contract. We're gonna use the read functions and the write functions we call and invoke. So for reading data with call, this is a structure. We're gonna call like this Starkli call. Now we're gonna pass the contract address. Yeah, we just get it the contract address here. So we're gonna pass this, and then we're gonna get the name. What is the name that we define at the moment we deploy the smart contract? So yeah, let's call it that way. Starkly deploy. Oh, sorry. Starkly call. We pass the address here or our smart contract, and we have to call the function. It's like a get name. Yeah, is it? Great. Here we have this value that is the same with this value, so no problem. But how can? But the idea was to read to set the name with a value that was called Starnet. What is Starnet? Yeah, here, yeah, Starnet book. That's what we want to see, but we only see all of this hash value that it's not easy to read. So for this, we have to make a new conversion. We have to parse to a Cairo string. So we're gonna pass this Starly parse string, pass a string. We pass here Starly parse Cairo string. Let's try to pass this one. Good, we got the started boot. Let's try to play with this. It might work as well. We have to pass the full value. Great. You see, we also get this started book. Yeah, let's put it here. So if you want to store strings in string values in your smart contract, this is the way how you can check what is the real value there. If you really want to, if you mean to store this value, okay, it's working now because we just did a conversion. We did a parse from this value to this, so it's working. It's good. Now we want to modify our smart contract. So remember to modify, to change, we have to call invoke. We have to call the function, yeah, set name. So let's do it now. Starkly invoke this time. Remember, it's not called Starkly invoke. Remember to get name, we write call, but here we have to write invoke. We pass our smart contract address. Now we call the selector of the function that we want to use. Call it set name. I want to change the name, but I want it to have a meaning. Yeah. So according to this, if I input this value, we are gonna store this string value Omar. But so let's try. I'm gonna input this. How it goes. So remember, Starly invoke the contract address selector. What is the name of the function? And I have to pass the input argument. I'm gonna pass this. Good, it means it's working. So let me call again. What's the value? Okay, I'm gonna do this. Starly call, get name. Let's see. So yeah, it's working. I set up this value and it's working here, this value. This is like on the felt format. I'm gonna check in the string format. I'm gonna use this. I'm gonna copy this value. I'm gonna delete all of these. Oh, great. So the string representation is Omar, so it's working. That's good. So yeah, that's it. Now you can play with this and see how it goes. So we try to explain with a really small example how to do this, how to interact with the blockchain with invoke and with call. I also want to show now because you're gonna maybe face some errors later, and we're gonna see what's the error we can face. For example, what happens if we change here. Remember, this is our deployed smart contract. But what happens if I change here instead of 7, I call 9? What do you think is going to happen? Since this is a contract address that is not deployed, so the blockchain cannot recognize this address. So we can get some error. So let's see here, you find this contract not found. So yeah, it makes sense. It means the blockchain cannot find this contract. Why? Because it's not deployed yet. Yeah. So yeah, this is one of the functions that we can get. Sorry, one of the errors we can get. So if you find this error, this contract not found, it could be like your contract is not deployed. Let's try T17 here. For example, what if I call this get names? Another contract error. Here they just say contract error, but I don't get too much information from here. But let's check here, for example. Yeah, we can check the logs in the Katana. We have all of these, but we can get this entry point not found, entry point selector. So it means like this entry point is, the name of this get names. So in our smart contract, we don't have a function called get names. We just have the get name. That's why they cannot find here the selector. Because in our ABI, they cannot find the selector get names. So if you find this error and this error entry point of fonts, it means like maybe you are passing the wrong name of your function. Because if you call get name, it's gonna work. Good. Yeah, we can also still playing here. For example, let's try to call, but let's try to call like this. Set name, I don't know, 0x55. Remember what I'm trying to do? I'm trying to call set name, but what should I do? I should call invoke, but now I'm calling call. So what's going to happen? Let's see. Nothing. So you see, nothing happens. Why? Because we are, we are passing here call should be invoke. If we call invoke, we are going to get a transaction here, but we got some empty output. So maybe the meaning is like we write call instead of invoke. So let's do it one more time. Invoke. Good. We got this value. We got this transaction. So it means it's working. What else? For example, what if I set name? I think that's all. Set name, just empty set name. Let's see how it goes. Oh, we just get contract error. We don't know what's going on. But so what happened here? When I call this set name, I should pass input argument. I didn't I didn't do it, so that's why I got this error. So let's check here in the logs of Katana. They say fail it to deserialize param number 1. So yeah, it means like they cannot read, they cannot get the first parameter. That's why I got this error. So I have to pass here 0x111 like this, and now it's working. So like you can see when you are writing your smart contract, maybe you are gonna get some errors. So the idea is to always analyze why do you get this error. You can get some info here from the output of your command or some info here in the Katana logs. It's gonna help you to debug your smart contract. And yeah, we can try many things. For example, let's try to declare something that is not exist. For example, I would like to declare this transaction contract. Here we can declare again our program. We have this path, but see, I changed something here. Just like this. They say no such file or directory. It means you are because why? Because we don't have this file here. Yeah, the full name is different. So we have passed a wrong path here. That's why no such file or directory. So we have to pass the correct name. My contract should be here. Hello, yeah. Hello. That's it, and we get a declare. What if we pass on a clash hash that is not? It doesn't exist. So let's try this. Starkli deploy. We have to pass this. This is like our clash hash. This is the one that exists, but let's change here 0. And then we have to pass what? Our constructor is going to be 0x111, let's say. You see, I just got this contract error, nothing else, but let's check here. If I got exception while running this control here plus hash plus file, it's not declared. Yeah, it's not declared, so that's good. So it means we are passing, we try to pass this clash hash that is not declared. So here should be E, and now it's gonna work. Good. And now we got a different instance, like we talked before, we are using the same clash hash, but every time that we deploy, we got a different instance, different contract address here. And then yeah, we can play like this. I think that's all for the errors with this. Yeah, let's move on. Let's move on the next example. Yeah, we finish this. Then now, yeah, here in the book they talk a bit more the Scarb and Katana. This is a homework for you guys. You read here but a bit more Scarb, a bit more about Katana. Now we're gonna jump into here. Here we have an example and testnet. This example we're gonna run again with Scarb, Starkli, and Katana, and then we're gonna run with Goerli. So first to this, we're gonna find the repo. Actually, it's gonna be, remember for this example, this is just a really small piece of code, but this time, this second example, the number of pieces of code is gonna increase. So I have the repo here. I'm gonna send you the link, guys, and update it a bit more. I have this on my local GitHub. This one, for example, repos, Cairo. This one, the ownable Starnet. So we're gonna play with this smart contract. And the idea is to deploy all of these with Katana, and let's see how it goes later. I have this contract here already, but what you can do is just git clone this repo. I'm gonna send you the link also later. Play with this. So here, for example, I have this. I have in public. Yeah, I have the ownable contract here. So for this, we can close this. We can stop Katana. We can close this example. We are done with this. Now we're gonna open the next example. Ownable smart contract CD. Okay, let's go code. Let's try to clear this. Clear. That's good. Okay. It's almost the same example like before. Yeah. It's the example like before, but we add more code here. Let's try to analyze what we have here. For example, this time we have to import this like contract address because we are gonna pass like an argument, a contract address. And we also import this try into, yeah, from the core of the StarNet. So like I mentioned before, we can define our interface for our data. We have like a data component here, a data element here on storage. So yeah, we have a get data, say data, and this other function is gonna work with the dispatcher. Just leave it like this for now. So for get data, remember we define like this, a T. Now, yeah, this is a more advanced example. We don't call a contract state. We just can call this T. It's like the trade, and it's gonna be at the end a contract state. So yeah, we just we define a snapshot for get data, and for say data we call a cell reference. We expect a new value here. For another functions, remember we're gonna work with the dispatcher. So the dispatcher needs to take some argument. So it's gonna take a smart contract address. We have to pass this. We are gonna call some data from this new contract address. Great. And also, this is the owner example. We're gonna work, with the owner of the contract. We're gonna play with this. Every time we're gonna check if the owner of the contract can apply can call some functions or can invoke some functions. Let's see. That's why we have this for ownership. We're gonna transfer the ownership of this smart contract to a new owner. So this new owner is also a contract address. This function owner just gonna read what is the current owner of this smart contract. Okay, we got now into the smart contract itself. We call here the dispatcher that we're going to need. For example, here we go the storage. In the storage, we have our owner. We store our owner, our data. We don't need this. We're going to store our owner and our data. Here, now we have defined one event. We're going to get a Starnet event, ownership transferred, ownership transferred. In this case, it's the same. This event, we define this event here. We have two keys. We're going to show what was the previous owner and who is the new owner. So every time we emit an event, we are going to emit these two values. Good. In the constructor, remember, we have this contract state. We are going to give a initial owner value. So the idea is the caller of the smart contract that is deploying this. I'm sorry, the user that is deploying the smart contract should be the initial owner. We're going to see the example there, and our data is a field. We just pass the number 1 here, but you can pass any number. We can call it U16. It could be. It's also going to work. So yeah, we have this. Now we have this implementation block. And on top of this, we call this external. First, let's see here. We just, like before, this is just our get data. We just read the value of data. But for say data, first we have to check. It's like we call the only owner. So it means only the owner can set data here, change the state of the smart contract. What is only owner? Should be here, here. So what only owner is going to do here is going to make a assert that the caller is, the one is calling this smart contract. This caller is the same like our owner that we registered before. Otherwise, we're going to see this error. Caller is not the owner. So every time we want to set a data, we have to assert, verify if the owner changes it. Okay, we can. Dispatcher value, dispatcher is the contract address, we're going to send it this. We're going to pass this. So for this other contract, we're going to read. We're going to call this function get data. Let's check later on the example how it's going to work. Now, let's talk more about the owner. So we have this function as well. This is another implementation block. So you see it's different. Here we implement the ownable data, but here we implement the ownable trait. So you can call this any kind of name that you like. Yeah, ownable data, ownable, yeah. Here we have this transfer ownership. Again, since it's going to change the state of the smart contract, we have to pass like this, self. We pass the new owner. Here we also have to check if it means who can change the ownership of the smart contract. Only the current owner can do it. So it's like the current owner is giving up to the ownership of the smart contract. So she's gonna give it to someone else. So for this, we have this. We can read this pre-owner. Who is the current owner now? Just read the owner. Then we have to write with the new owner. So we get this new owner, and then we can emit an event. Yeah, this is our event we have defined before above. So we emit an event with the previous owner and with the new owner. This is like it could be like a read get owner or read owner. Let's call it read owner. Owner. Here I got this error because I have to change here as well. Owner, read owner, my interface, here read owner, but there might be someone else. Let's try to find it. Owner. Okay, I think it's okay. It should be working now. Okay, read owner. Yes. Okay. Good. Yeah, we also have here the only owner that we talked before. We have some tests. We're gonna talk test later, next lesson, not now. Okay, we explain about the smart contract. Let's see if it compiles or not. Scarb. Oh, good. It's working. Now, remember, we're gonna, for this example, we also wanna work with katana. So we have to run katana. So here, there's katana disable key. And then we have to set up our environment values. I'm gonna set up, I'm gonna copy and paste. Okay. I'm gonna use the same like before, not this, not this. Let me open the other values. Here, remember in my example before, this was my contract. Um, I have these environment values. I'm gonna use the same for now. I'm gonna call this. I'm gonna. Okay, I'm gonna work with this. Be like this. Yeah, the same. Okay. Now I'm gonna read the value source dot end. Let's see if I can read this RPC. But I have to read like this. So, oh, my bad. Like this. I'm gonna clear one more time. So, okay. Good. Now our terminal can read these values, so it's gonna work. So I already did my Scarb build. Let me do one more time. I have my value, my files there. Now I have to declare. Remember, for declare, I have to go with Starkli. Starkli declare. Have to pass the file that this file contract class. This contract class. In my case, it's called Cairo 1 B2 ownable. So let's do it. Cairo 1. No, it should be target. There. Cairo 1 B2 ownable contract class. JSON. Great, good. Now it's working. It's working. We got our class house. So now that we declare, we have to deploy. But remember, what is a constructor? In the constructor, we have to pass address. So what is the address of this? Let's just pass since this is Katana 0, here we have to pass, we can pass this address, like the initial owner is the same like this Katana 0 here. So no problem there. So let's do it. See, okay, later, okay. I have to do it this way. Starkly deploy. I have to pass the class hash. Then I have to pass the constructor. The constructor is looking for a contract address, then for the owner. I have to pass this. Okay, good. Yeah, I got my contract deployed. Awesome. After this, what do we do? Let's play with this. So let me read some functions there. Get data. Let me call the data. So Starkly call. This is leave it here. Yeah. Starkly call. We have to pass the contract address. We have to pass some function here. Get data. Data. How is it? One. Yeah. Remember, when we call the constructor, it's going to set up with one. So it's okay. We can also call the owner, yeah? So let's check read. Let's call read owner. Starkly call read owner. Here, read owner. Owner. Good. So I got this address. This is the same address that I have here first. So great. Well, they just did a padding with 0, but it's still fine. But it's the same address at the end. Okay, so it's working with smart contract, but let's try to modify here the set data. Remember, only owner can do this. So let's see if it's working or not. Remember, if we're gonna change something in the state, we have to call invoke here. At the end, we keep the same smart contract address, and then we call set data. We have to pass some new value. Let's call it 08. 0x, let's see how it goes. Great, it's working. It's called get data 0x to 2. So it means my only owner is working well. It means the caller address is this address as well. So actually this address is the caller address. So although you can see I'm using Katana, yeah, I didn't use this explicitly, this address, by using this katana, but like I mentioned before, inside of this, the account address is this one. It has a balance. It has it there. It's just for for a testing, so it's working great. So let's try to work now with the with the transfer ownership. Yeah, with the transfer ownership or with another contract. Now, first, let's try with this other function. Let's try to deploy one more time our contract and check how this other function works. So remember, we can keep the same class hash, but we can, let's do this, deploy. We are gonna deploy this. We keep our same class hash, and let's try to use another different address. Oh, no. Account address is here. Account address is here. So we're gonna deploy one more time our smart contract, but this time we're gonna pass different owner. This is some contract address that we get there. Let's see how it goes. Great. So now I have a new project contract in the number 2. Let's try to save it somewhere else. Contract 2 is this. Contract 2 is this. Contract 1 is check here. This one, contract deploy. Great. So let's keep here. We have contract 1 with this initial owner, with the first one, and we have a contract 2 with a different owner, a different initial owner. So what we can do, for example, in this other function, we can pass this contract. So we're gonna go back to the first smart contract address, and we're gonna pass the second here. We are gonna still working on this contract 1, but we are gonna pass this contract address 2. Let's see how it goes. Starkli, no, it should be or invoke. Should be invoke. Invoke. We're gonna keep the first smart contract 04. Let's check it 04. Yeah, 04. We are gonna call now trans other function. Yeah, other function, and then we have to pass a other contract. The other contract is gonna be the number 2. I have to pass this other contract here, and then what it's gonna do is gonna read the get data from this contract. Remember, we just build a constructor for this contract. So when we build the constructor here, the default value is 1. So we should expect to get the number 1 here. So let's do it. It's working in bulk, another function. Can get it here. Yeah, now let's try to read the value from our contract. Starkli deploy, Starkli here, get data. The data is still true, yeah? Remember, we just change this on our contract number 1, but for our contract number 2, we can do the same. We just change this value. So let's do it Starkli call. Let's pass the contract number 2. This is this one. Number 2. Get data. Great. Is the number 1 now. That's how it works. But now let's try something. Let's try to set data in our second smart contract. We just did get data. Let's try to set data. Set data in our, let's call it like 0x5. What do you think is going to happen? I got an error. I got this error. So what does it mean? Error data execution. They didn't give me that much information. Execution error data failed. Actually, what's going on here is like I'm not the owner of this contract. You see, every time that I'm going to try to set data, I must be the owner. Only the owner can do it. But remember, who is the owner of this data? I mean, of this customer contract is this one. Oh, sorry. Here, this one. This is the owner, but I don't have access to this user. Yeah, this is one user that wants to interact, but I don't have the access for this. So I cannot change anything on this set data because my user is this one. my user ID is this is my account, and this account is related with the owner of the first smart contract. But for the second smart contract, I don't have the credentials to become a user. So yeah, that's why I cannot make this set data, or I cannot even make a transfer function. I'm gonna get the same error. So yeah, but we can do it with this on testnet. So on testnet, I have my own wallet address, and I can play with set data, and I can play with the transfer ownership there. But yeah, I just want to show this example with Katana and how it goes. So now let's move to this the same example, but with a different environment. We're gonna do it with Go early testnet. So yeah, let's stop this now. Let's stop it. Let's clear this. Let's read a bit the book. The book here. Yeah, let's jump into here. So now we have to make sure we have the Starkli. For this time, now we have to work with this. We have this with Argent or Bravos. So in this example, you must to create your own smart wallet. Could be Argent or Bravos, any of them. And then on that way, if you have that, we can play with Starnet Go early. So we are not gonna use a Katana anymore, but we have to get our smart wallet set up. Here, yeah, like they say, you have to get Bravos and Argent, the Starnet faucet. You have to find your account and all of these. You have to deploy and everything there. Just try to follow these rules. I'm not gonna follow this. You can do it because it's a bit sensitive. I mean, you have to create your wallet. You're gonna get your seed. You're gonna get your private key there. So I think you guys can do this. I'm just gonna skip it this part. But yeah, I can help with this, with create a signal and everything there. So let's say you already have your wallet, like me, I have my wallet, you already have your wallet. So if you want to, so now we have to create a signal in our local machine. In order to do that, let's follow this example. I already have mine, but let me delete it. I can do it one more time. It's not a big deal. I clear this. Give me a minute to delete my. Okay. I'm kind of clean. I, I'm gonna clean this. Let's do it together. So let's do like this. Okay. So we have to create this local file for the deployer. Let's try just to follow this. So yeah, it means it got created the file. Then we have to generate this file, my key store. So let's do it. I'm gonna try to follow this. Oh, sorry. Here we use a Starkli to create a signal, the key store from key deployer. We have this, my key store one. Here you can change the name. In my case, I'm gonna use something. I'm gonna call it Argent because I have an Argent account here. So let's do it, Argent. I have to input my private key. So for this, yeah, you have to open your private key from your wallet. I'm gonna do it, but in a private way. Okay, I already got my private key. You also can get your private key. I'm gonna input my password. Great. So let's check here. So like they say, you have to open your Bravos or Argent wallet, and then you have to find to export the private key. I already did it. I didn't show because for privacy, but you just can follow this. Just open your Argent, look, find the settings, export private key, and just try to copy and paste. I copy and then I paste here, and then you have to enter a password. It could be a new password for you, just something that you have to remember. And then we get this new file. It's gonna help us, to find the transactions. Here you have to read this to get more idea about it. This is optional. It's up to you about architecture, what's going on there with the private key, public key, smart wallet address. Yeah, I'm gonna leave it for you there. And then the second step, we already got this key store file. We also need the account file. So for this, the same, we are gonna use Starkli to fetch our Argent wallet. To fetch our Argent wallet, so here, Starkli account fetch, we have to pass our smart wallet address. In my case, my smart wallet address is this, so no problem for minutes. Is this my smart wallet address? Just your wallet address, and then we have to pass this. Yeah, let's copy this. Okay. Here we can change the name up to you. In my case, I like to call it Argent. You're gonna know why later. Argent. Okay, I have this. What happened here? Didn't match one. Started record fetch. Getting back to some sequential gateway. Oh, I think I have to read my RPC output wallet tally fetch. My account output deployer. No, what is provided? Provided for multiple. Let's check here. I think we cannot use the yeah. We have to pass RPC here, and so in our case, let's jump here and let's jump into here. Yeah, this. Now we have to pass the provider before. We cannot use the current sequential gateway. So we have to choose a provider. It could be any of them, like Infura, Alchemy, ChainShape. Maybe if you remember, if you worked with Solidity before, you have to pass well RPC URL. So for this, you have to create an Alchemy account or Infura and pass the provider there. So in my case, I have mine, my provider. I can show this here, that dashboard. So for example, this is the provider that I use for testnet. I can check my API. This is my key. I'm gonna copy. So, oh, mm, it- okay. Yeah, let's try one more time, but I have to pass here the RPC. Let's follow what is RPC. What's the name of the parameter? Only RPC. Only RPC, and we have to pass the provider. Do like this. Goes great. So now, yeah, before you can do like this, but now since the sequential gateway it got deprecated, now you have to pass your own RPC URL here in order to deploy something with Starly. Okay, again, that's good news there. So now let's see. Uh, let's let's go here. Let's see what do we have here. CD. So now we have these two files. That's good. So with these two files, we can sign the transactions and we can interact with the blockchain. So awesome. Let's continue working on this. This is the book. Oh, this is the Starly book. You also can check there. We're gonna follow this. Remember, yeah, we did this. We apply this command. Now we can jump into here. Yeah, the account and the key store. So now, like before, we have to set up the environment, but this time it's going to be according to your files, yeah, your local files. Here is my account one, but in my case is clear. I'm going to clear this. It is my account agent and my key store agent. So I have to copy and paste this and change it with agent. So here I have the environment file. I have to change it with this. I'm gonna copy. Here is Bravos. I have to change with my local agent, agent, oh, agent. Okay. And now I have to pass as well the RPC provider. This is the one that I use. You have to get your own from Alchemy. So you create your account in Alchemy and just find the Starnet Goerli API there. This is mine, like I mentioned. Yeah. So I have this, I have this. Great. Now I have to read the source EMB, source EMB. Let's call it this. Okay. Source EMB. Let's see if this is works. Great. Now this variable is pointing to this file, not like before. It was pointing to a katana, yeah. But now it points to this file, so it means it's working. So now let's continue with this. What did I say? Yeah, let's jump into here. Yeah, it's pointing there. Now we have to scar build and declare, export. We already did this, declare. Yeah, same like before. We have to build and then we have to declare with our RPC. Let's see. Let's try scar build one more time. Scar build, great, it's working. Scar, no, Starly declare. Starly declare. We have to pass the file. Usually target deb is this kind of contract, ownable contract plus JSON. Yeah. I think we also have to pass the RPC. RPC is which one? Is this one I'm using? Let's try like this first, how it goes. Yeah, for declare they don't ask this, but for deploy they are gonna ask for the RPC. Okay, I got this clash hash. Is declared. Now, according to the book, I should deploy now. Declare. See, according to start URL, Starkli can recognize the target function network in physical early. So let's see. Okay, okay. You can read all of this to get more idea. I'm just gonna go to the point. We got the clash hash. The clash hash. Oh, we can check this on Scar scan. Yeah, let's open Scar scan. Let's see if we can check here this contract, this clash hash in Scar scan. For example, here I have to change class. There we go for this. Let's go to Scar scan. No found, no found. Testnet, yeah, testnet, search. Here, I think they have, let's open from here. Slash hash, declaring hash, component declaration. Wait, let's try one more time. Otherwise, yes, let's check later. Events, control, code, crash. Yeah, it's not fully declared. We still have to proceed. Let's move on. Now, what is this? Here. Yeah, to verify, release, contract, deploy. Let's deploy first, and better we check the contract address after we deploy. So for this, the same, we have to deploy, pass the clash hash and the constructor input. So let's go for it. Starkli, deploy. We have to pass this, have to pass this, and deploy. And then what is the constructor here? The constructor is, we have to pass the owner. In this case, I'm gonna pass, since I'm the owner, so I have to pass the address of this here, my account. I already set up my wallet with Argent, so I'm gonna pass my wallet address here. Let's do it. My wallet address is this. Okay, I'm gonna pass my wallet address. That should be the same like the one I link it here. Let's see how it goes. Password. Great. It's working. Now let's try to find this on Scan. It might be there. Let's see. Let's see. Here. Wait. This Scan. Here. Let's search here. Here. Other. Taking some time. Let's try to the other. Voyager. Let's take with Voyager. 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 Voyager here. Voyager. Here. Okay. Here, go early. Let me try this. Okay, it found it here with Voyager. So like I said, yeah, I just this is the date. Got it. Transactions, events, message, account calls, read contract, write contract. Yes, loading. Yeah, but yeah. Now it's working here. My contract. Let me try with the other one. I think my class hash also might be here. What is my class hash? Let's try there in Voyager. Voyager, go early. Let's see if we can find it. Oh, they found it here. And then you can see it's class. It's different for contract address. They call it contract, but for this class hash, it's class. And that's it. You can see the ABI and the bytecode here. Great. So try to find Voyager next time you want to explore the transaction. Let's go back here. Let's go back here. Okay, we have this. We have this working there. So one important thing also is you can check. Now we don't have the logs here. Remember in Katana we have some logs in this part. We don't have the log here, but we have in the here in the alchemy. We can go to here to our response. Yeah, we can update this to our latest responses. What's on? So you can find the logs here of what's going on. You can see this success. Just a few minutes ago, what we did. So in case we have some error, you also can check these logs to try to debug your smart contract. So let's keep it for now like this. Okay, let's follow the book. For the book, we'll deploy this. They have the clash hash and the wallet address like this. Come. So to interact, we do the same. We call the get owner and let's see how it goes. Let's have to do it. Starkli call our contract address, and then we call get data. That's our name or no? Yeah, get data one, and then read owner. Yeah, we also have read owner here. Owner. Great. This is my wallet address. I'm the owner. That's good. So I also can try to change the here. Let's gonna try to invoke there. Read owner. Yeah, read owner. And I try to set data. Let's call it 0x 555. I try to input my password. Great, they did it so quick. So I update the state of the blockchain. I can see here in Voyager again. Let's go to Voyager, and I have this. I'm gonna check this transaction. What's going on in this transaction? Okay, this address, this hash is related to a transaction. It's already set it on L2, so it's going so fast there. Just a minute ago. I spent all of this during the. So yeah, let's wait for a minute in order to pass to be affected on L1. Okay. So, like you see, we have saved the data, we interact with the blockchain on testnet. Here, this is the transaction hash that we get. You can see it's easily so quick affected on L2, but it's gonna take a few minutes to be affected on L1. And yeah, it's like this actually, so no problem for that. As long as it is affected on L2, we can work. So great, we have this we apply this call and invoke for read owner, set owner, and data. So now let's try to do something different. So we have to let's try to deploy a different contract. No, a new more smart contract, but with a different owner. Remember when I deploy it, then I deploy it with my own, with my wallet address from Argent. It's the same like this, like the owner. But now let's do it one more time. But let's use a different wallet. For example, I'm gonna use Bravos now. So I'm gonna provide a different smart wallet address. So, but for this, we also have to, we also have to store these values for Bravos here. So I'm gonna repeat the same steps like I did before. So let's read the book. What should we do? Remember, we have to go back, and this time to the book. I have to create. I have created this, but I'm gonna create one more time, one more key store. But this time it's gonna be for my Bravos wallet. Here I'm gonna call it Bravos. Bravos. They are gonna ask for my private key. I'm gonna pass my private key. You have to do the same, but in a private way. Okay. I just got my private key. I'm gonna paste it here. I need to input a password. It can be any password, a new password for you. Yeah, but you have to remember. Great, I got this file. Now I have to go this. Wait, fetch. I have to fetch like this. Okay, I'm gonna delete this. I have to fetch this. Starting account fetch. Here I have to pass my wallet address, but it comes from Bravos. So from Bravos, which one is this? This one. Okay. This is my wallet address from Bravos. I'm gonna go here, Bravos. Okay, I like before I have to pass the ERPC URL, and for the URPC it can be the same, no problem for that. I'm just gonna use this. Can be for everything. Yeah, Bravos, good. I I have this. So now here you see I have my account for Argent, I my key store for Argent, my key store for Bravos, and my account for Bravos. I have all of these two. I need these two in order to interact with the smart contract, yeah? Because I'm gonna lose, I'm gonna give up for the ownership of the smart contract from here, but I have to send it here to the Bravos. So let's see. How do we do? Starkli deploy this, not deploy. Let's call this function now. Let's call the function transfer ownership. Okay, I'm gonna transfer the ownership to my Bravos account. So invoke here. So this is my Argent account. Now the user behind all of this is my owner. My is this one, yeah. This is my Argent account. This is gonna invoke the smart contract, and this is gonna transfer. You're gonna call this transfer ownership. You're gonna transfer to my Bravos account. My Bravos account is this one. I wanna press it. Oh, no. It didn't. Oh, my Bravos account is this one. Okay, this is my Bravos account. I'm gonna do it. I have to keep. I have to enter the password for my Argent account. Let's see how it goes. Great, it's working. So now, if we call the owner, call read owner, you can see this is my Bravos account, not like before. Before we call owner, it was my artist account, but now it's my Bravos account. So if I try to set data, what's going to happen? Let's try to set data. Set data. Let's call it 777. Asking for this. I just got this error, internal error. So what's going on? So like I said, you have to check on your provider here on your dashboard what's going on. Try to update it. You're gonna find the answer then. You have this raw response, and you can see here this one. Caller is not the owner. So it means, yeah, because it's true. Actually, what we try to do is set data, no? So if we want to call this set data, the owner of the caller of this uh, function should be this address. But now, who is the caller? The caller is this, the urgent one. So now we have to change, we have to switch our environment variables to use the Bravos account. That's why I have this here, my Bravos. Yeah, it's working there. Let's change it here and copy. Yeah, delete it here. So what you can do is this, you can create a new variable here, MB. I can call it 2 and 2. So here you just have to change the with your local Bravos. Great. So remember you have to update the variables here. So that end. Let's try to call this. So Okay. No. Remember, I have to update with M2. I did it to M1. It should be M2. Okay, this one, this file. I want to update with this file. And great. Now I can get the Bravos. Remember, you have to create a second environment file and update with your second account. It's Bravos in this case. So now the color will be the Bravos account. And the Bravos account is the owner, so it can change the data. So let's do it one more time. Invoke. We have this smart contract data with 77. Awesome. So you can see I can now change the value, yeah, the state of the smart contract. But for this, to accomplish this, I have to, have to know all the credentials for this wallet address for Bravos and Argent. So good, that's good. Now what we can see also, we have to, so who is the owner of this? We can check again. This is the Bravos account, read owner. So let's go back to let's say, okay, now I want to give this ownership to the first wallet address, to the Argent account. So let's try to do it. Now we call again transfer ownership, but I have to pass my Argent account. My Argent account is here. So yeah, transfer ownership to my Argent account. Let's read the owner. Wait. Let's invoke. It's gonna take a few minutes for this. So again, ownership, return. Let's transfer ownership here. So now what we can do is let's try to deploy a new contract. We're gonna see this is gonna get a different contract address. So let's try to deploy here one more time. Let's try to deploy, but with our Bravos account. We deploy it with our yeah. But let's save this contract one. Yeah. Let's do one more time this. We're gonna save our contract one. Remember, this is our contract one. Here, contract one. Now, contract two. Let's try to deploy our contract two with our Bravos account. For my Bravos account, I have this. I'm gonna get a different account. Great. So I get now this contract address. Let me save it here in case. Okay, I have the contract two. So from our contract two, let's call our contract one. So what we can do is this. Let's see if it is working there. First, we have to call. Let's clear. I think. Let's keep it like that. Starkli call this the second contract, and then after call we have the get data. We have this one. Now we have read owner. This one. This is the same like my wallet, my active wallet. So that's fine. Good. After this, so let's call the dispatcher. Let's call it one more time. Remember, we have this function here. Other function, we have to pass a smart contract, and the dispatcher is going to call the data from there. So let's see. Starkli invoke this time is called. Starkli call. This read owner should be dispatcher here. Should be transfer other function. In this other function, like you see, I have to pass the contact address. I'm gonna pass the contact address from the first one. Yeah, let's see how it goes. Great. So what we can see here, remember, so the dispatcher, what he's doing, dispatcher is working here, is gonna read the data, the value of the smart contract number one. So it's calling this get data, but from the smart contract number one. Because from our smart contract number two, we have the value is one. But for the for the second smart contract with Bravos, we have this value, it's number one. But here we pass our first smart contract and we are calling get data from there. And it is 777. If you remember before, we have we checked the data here. We set data to 77 here, to 77, and it works. So now we call it from our second smart contract to the data there. So yeah, that's why how you can use Dispatcher on your smart contract. Yeah, I think that's all for now for this lesson. We did a lot. We played a lot with the smart contract. Just try to do the same, follow the steps, try to, if you get some errors, try to understand what the error was, the meaning, and practice in order to get more familiar with this way to interact with the starnet. Okay? Yeah, I think that's all for now. See you next time.